Section 7.4, Adding and Subtracting Polynomials. So this is a pretty straightforward section. We're going to be doing a lot of vocabulary work in class, but in the meantime, we want to look at some of the general applications of what we have to do here. When you're adding and subtracting polynomials, I have examples of polynomials around this triangle here. 6x plus 2, x squared plus 5, 2x squared plus 3x minus 4. Those are all polynomials. You can see that they're combinations of coefficients and variables and exponents, constants, all connected with addition and subtraction. And that's generally the look of the polynomials we're going to be working with. And so one thing that we can do with them is we can add and subtract them. And so an example where we could do that is if I'm being asked to determine the perimeter of this triangle. Now I know that perimeter means that I have to add up all three sides. So I can say I got 1, 2, and 3 sides. And I'm just going to add them together. So I'm going to write out what that would look like here. I'm going to use the symbol P for my perimeter. And I'm going to say that equals, to take my first side, which is 6x plus 2, plus my next side, which is x squared plus 5, plus my last side, which is 2x squared plus 3x minus 4. Now you'll notice the directions here say that I can express my answer as a polynomial, which makes sense because I don't have a number yet. This is not going to get a specific answer here. So in order to do this, what I have to do is I have to combine like terms. So I'm going to look first for the thing with the largest degree, the largest exponent. The largest exponent in this polynomial is a 6x, is my largest exponent there. I don't have one. But I do have an x squared in the next one as well as in the last one. So if I actually combine those, I've got x squared plus 2x squared is going to equal 3x squared. And maybe I even just want to cross those off to show that I've used them. Now I'll go to the next thing, which is just going to be my x's. So I've got 6x, I get nothing in the middle one, and I've got a plus 3x. So I'm going to combine those, and 6x plus 3x is plus 9x. So I've taken care of these two right here. And then finally, I've got my constants, just my regular numbers here. I've got a 2, adding 5 would make 7, and then I actually am going to subtract 4. So 2 plus 5 is 7, minus 4 is still positive, but it's plus 3, and that's using these 3 right here. So now I've combined all of my like terms, and this is actually going to be the expression for my perimeter. It's 3x squared plus 9x plus 3. And so what I can do with that now is I can actually evaluate the perimeter given different values for x. So I'm just going to start by putting in these two numbers here. I've got to evaluate the perimeter when x equals 3. Now if I hadn't done all this work, I'd have to plug x equals 3 in here, here, and here. Then add those up. Now I don't have to. I can just plug it in here. So I'm going to get p equals 3 times 3 squared plus 9 times 3 plus 3. 3 times 3 squared is 9, times 3 is 27. Oops, wrote 29. Let's change that up there. 20, a little messy. That's okay. Well, good to go. 27 plus 9 times 3 is also 27 plus 3. And, of course, that equals 27 plus 27 is 54. Plus 3 is 57, I'll call it units. And there we have it. All right, what about when x equals 4? Well, just plug it back into the exact same formula that I have there. 3 times 4 squared plus 9 times 4 plus 3. And so 4 squared is 16, times 3 is 48, 9 times 4 is 36, and we just get 48 plus 36 is 84, plus 3 is 87 units. So depending on what I had for my value of x, I've got two different values for my perimeter. Either it's 57 units or 87 units, and I could plug in anything else for x, but I don't have to plug in 3 times each time because I added these polynomials originally. So that's all you have to do. You just have to combine like terms, and you do that. We've been doing that for a while, so that shouldn't be too difficult. The one thing you have to be careful about when you're combining polynomials is subtraction. And just a common mistake, when you have subtraction, you've got to make sure that you take the subtraction and distribute that negative to everything that comes after it. This is going to change any signs from plus to minus and minus to plus. Just a really important first step to take, and then you just combine like terms from there. So I'm going to start by rewriting. I'm going to keep the first part the same. That's 5x to the 4th minus 3x squared plus 7x minus 3. And now when I distribute that negative, I get a minus x to the 5th minus 2x squared. Now the next one is minus the negative 6x. That's going to turn it into plus 6x. It's going to turn the last thing into plus 3. So now that I have distributed that negative, I can just combine my like terms. And you can really write them in any order, but it's always nice if we find the largest exponent and then go from there. So when I search through, it looks like I've got a negative x to the 5th is going to be what I have there as my starting point. So I'll cross that one off because I've taken care of that one. Then, and there's no other x to the 5th, then I look through again and I see just the 5x to the 4th. Now, I don't have anything up there originally, but it's positive, so I have to use a plus 5x to the 4th. So I get that one there. I'm looking, do I have anything with the cubed? And it does not appear that I do, so I just skip it. I don't need to put a 0x cubed, I just skip it there. Look for something squared. I'll get a negative 3x squared and a negative 2x squared. So a negative 3 minus 2 is negative 5x squared. So I'll cross those two off. On to the x's, that's a plus 7x and a plus 6x. So a plus 7 plus 6 is plus 13x. So I can cross those two off. And then with the constants, I'm left with minus 3 and plus 3, which actually cancel out, and so there's nothing left. So I will just leave this as my final answer. So I have negative x to the 5th plus 5x to the 4th minus 5x squared plus 13x. And that's my resulting answer. And there's some vocabulary that we'll look at in here, or we'll already have looked at in class. This is a polynomial. It has a degree 5 because it's the largest exponent in the polynomial. It's in a nice order here. We call this oftentimes a standard form, or we're writing it in decreasing degree, which is a nice order to put it. The first coefficient is a -1. That's called our lead coefficient. So there's some things that you'll see, but there we go. That's all that you need to know about how to add and subtract polynomials.